Okay. Last time my video got cut off, so we're redoing everything, and let's start with GCD. All right, so I want to do this really fast before it breaks again. I don't know how it break, so this is my third attempt. Hopefully it works this time, and you'll see an actual video that's good. Um, Oh, you'll see the failure video where it got cut off. I don't know why it got cut off, but we'll see. Now, over here we got A equal 12 and B equal 18. That equals 3, 4 and 2, 2. And we got 2, 9 and 3, 3. We see here 6 and we see here 6. So 6, 6. So that's a common one. So that's the common divisor. It's leaving us with 3, 4, 6. As you can see, we see 6 here, we see 3 here, we see 2 over here. And then we see 1 secretly everywhere because everything turns to 1 multiply everything. So there we go. Um, and then 12 and 18 are not here because they're not divisible by each other. If they were divisible by each other, we would have saw it and we would have, you know, put it there. But no. So that will make us the highest thing. This is a GCD. We got it. All right, we're gonna go to uh least common multiple, which is done by integer equal 1, comma 2, comma 3, comma 4, comma 5, comma to n over here. And we multiply that by 4, 4n over here, which is 4, 8, 12, 16, and so on. And then we do the same thing with 6n, which is 6, 12, and then so on. And then we find 12, 12. That's the least one. So LCM equals 12. As you can see, I'm losing patience because I've done this same part of the lecture uh, 3 times already. I should explain the definition although, but I think you get it. The how I showed you with writing makes more sense, Matt. But if you want to know the definition, let A and B be integer with both non-zeros. We call who cares about definition when you can actually see the actual match, which is way, way faster. Anyways, whatever I'm doing, we're gonna prove this relationship here. Um, A comma B. This is multiple. So first thing you have to say is we're gonna get to something like this. Now, GCD already get rid of the top contenders. So over here, you see over here, A equal 12 and B equal 18. We see that D equals 6. D is GCD, as we know. And we know A prime, B prime are composite functions. I call it that. It's not actually called composite, but these two, when you multiply this, it get you this. When you multiply this, it get you that. S- okay, so what I'm basically saying is that with these two, you can get A and B original. Very simple, very simple. Now, I did 2 examples to showcase it because um, I realized my first example can be mistaken as maybe there's a relationship with prime number. No, there isn't. This can happen. So this doesn't have either. So as you know, then A, B can equal D A pi, and then prime, and then B prime. So you see over here, we get that function. Now, you know this is GCD automatically. Now this over here has to equal LCM to be true. Now, how could this be anywhere close to LCM? Well, look at these two. Now, my proof goes into a little bit of weird details, but what you need to realize is that GCD of these two equal 1. What that means is that um, for LCM to exist, those two numbers must be multiplied into each other to get anything coherent as a LCM because these are independent um, composite functions that make up that. Is what I'm saying. Does that make sense? I hope it does. Now, now, why would that ever be important? Eh, I haven't used it ever, but you can see how you can get something very fast with A equal and B equal 14. These are large numbers. If you were to do n equal 1, comma 2, comma 3, comma 4, let me just do 36. And oh my God, that's already 6, 12. What the fudge? I can't do that. No. It's 12, 72. I can do it actually. And then you get the point. It becomes painful, and I'm just gonna grab a calculator over here and then do it probably. But as you see, it's 256, and then 252 is the actual answer, which is by my calculator is it is integer 14 or something, 18 or something that gets you. So 18 multiplied by 14. So you're gonna have to go to 18 of these n's. So you're gonna have to go 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 of these n's to figure out that. And we have no time for that. Although honestly, I don't really know. I mean, there probably is a use for it and something else. But I just use a computer at this point. Um, so I would use a computer. You get the point. What I'm saying. Anyways, so then you could say that with this calculation, LCM A comma B equals 36 by 4 multiplied by 14. Absolute value by 2, which equals 252. Now, the thing is this really that important? Well, how about if you want the LCM of A comma B comma C? Well, then this equation would be obviously useless for me. Oh no, I don't know the use for it. I might have a use for it. Someone else might have a use for it. I don't. Now we're going to prime numbers real quick because prime numbers are fun. Um, Now, as you can see, I'm getting pretty annoyed because it's my third time trying to do this lecture. So I might want to do chapter one again later on, but this is only try, so who cares? So prime numbers are p equal 1 multiplied by some by itself basically, and I wrote a times b over here, because technically, formally, that is more correct, right? Because you wouldn't know it, but yeah. But this gives it away. Now, if the prime number is a negative, it's a why would it be a negative one? Um, I actually I think I'm wrong about that. I've never seen that possible. Okay. Uh, that's awkward. I already got something wrong with that. Anyways, so we know that 1 multiplied 2 equal to, fun fact, this is the only, oh my God, only even prime number. Because if you think about it, after anything is divisible by 2 in 2n, which is how you define a prime even number, right? Hmm. So every number after that must be odd to be a prime number. We already discussed this. Now, okay. So here's a few cool primes. Um, Honestly, never used them. Just they're cool. So I mean, if someone uses my textbook, I know there's going to be one grouchy teacher that would put this in a test for no reason at all, even though, like, why would you ever need to know this? All right, n equal 2, just something cool. N equals 17, and 17 is a prime. There's a few of these actually. Um, I don't know. I can search up on the internet how many. P equal 5. You plug it back here, you get 31. That's the nursing, but it doesn't really matter. These names don't matter because I've never seen a prime be useful. I mean, I've seen a prime be useful, but I've never seen higher. What's the right word? I'm not. I'm just gonna be quiet. There are certain uses for it. You get the point of that. But here's a question made up that's a pain in the ass. I mean, I literally just had chat get me all these prime numbers because I couldn't do it by my hand, though. Yeah, I didn't want to do it. So ChatGPT did the question kind of for me. Like it got me those primes, which is awesome because I didn't want to do it. And you can see there's a sequence thing. Um, yeah, just something like this. Yeah, and I got my answer wrong. So yay! Anyway, there's one, two, three, four. There's two. So there's eight of them. Okay. And whole point of this I wanted to show was not about this, show that the primes get less frequent as we go along further and further and further. That's the whole point. Anyways, yeah, I used chat for this one because I was like, not doing it prime by hand. But yeah, the whole point of this was to show that the prime numbers get fewer and fewer as we go on and on and on and on. Um, yeah. And kind of shows you because pairings, right? Yeah, pairings, right? Yeah. Um, I wonder if no. The fun fact is, if it wasn't plus two, it wouldn't work because then you have an even number, which will automatically not be a prime. So you have to do plus two, or it won't work. Yeah, but you can clearly see from here at fi the 50 mark, there's less over here than the top over here. That's kind of what I wanted to show. And you kind of see it here. And why did I add the plus two? Because I want to show the frequency of the separation a little bit. Now, plus two is like two digits off of it. So it kind of shows that off a little bit that the separation is going to grow, 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 grow. And yeah. Kind of. That's kind of the idea of that question, anyways. Now, fun, important numbers, the universe number, so the ratio of a circle and the golden ratio. Golden ratio I put there because it was my geometric project, basically, in ninth grade. Ratio of a circle, that's always necessary. And Euler's number, who doesn't know that? Euler's number, sorry. I forgot that's how you say it. Anyway, I'll make a recap video of all of this in chapter one. Anyways, I'm done. Oh shit. Who cares? No one's watching.